Hello everyone, welcome to another lecture of CUFI 320. In today's lecture we are going to cover one of the techniques of multiplexing. So let's talk about time division multiplexing. What is time division multiplexing, or TDM in short? Basically is one of the multiplexing technique that works with digital signals. The process basically consists of merging several connections that can share a high bandwidth of the link. If you remember, when we talk about FDM or frequency division multiplexing, there we were sharing a portion of the bandwidth for each channel. However, in time division multiplexing, we are not going to share any portion of the bandwidth. Rather than, what we are going to share is a particular time. That is, each connections will have a particular time given. During that time, they can use the entire bandwidth to transfer their data. Let's go back to FDM example so that you can understand perfectly what is the difference between FDM and TDM. Suppose we have these three input lines. This is from source 1, this is from source 2, and this is from source 3, and we are using FDM technique. In that case, we have suppose this bandwidth, and now here we have the output lines for source 1, source 2 and source 3, the corresponding destinations. So here suppose source 1 has 4k byte as requirement, source 2 has another 4k byte, and source 3 has another 4k byte. In total, this bandwidth line has 12k byte. So if we use FDM, so what we have been done is basically share this 12k bytes to each of the sources. So first 4k byte will be given to source 1, second 4k byte will be given to source 2, and last 4k byte will be given to source 3. This is how the portion of bandwidth was shared among these three connections if we use FDM. However, in TDM we are not supposed to share this portion of bandwidth. Rather than that, what we are going to share is some time. We are going to give some time to source 1, then the same amount of time will be given to source 2, and then the amount again will be given to source 3, and so on. Let's see the diagram. Here we have an example where we can visualize how these sources are sharing the time. We have here source 1 or connection 1, you can be anything, source 3 and source 4. And these are the corresponding destinations, or the corresponding destinations for each sources. So here you can see in the diagram we are giving some time, mentioning as 1, 2, 3, 4. That is, this one time is given to my source 1, and during this time source 1 can transfer any data to its destination, and it have all the bandwidth available for it. Similarly, source 2 will be having this time, the T2 for its connection, and will have the entire bandwidth to transfer that data. Same for source 3 and source 4. After completing one cycle of all these sources that are given already their appropriate amount, again they will start from the first one to the last one. So again source 1 will be given another time to complete the transfer, then again source 2, source 3 and source 4. Again completing this cycle will given another time, and so on. So So basically till they end the connection, they will be giving some equal amount of time to transfer that data, and during that time they will have all the bandwidth available for it. So TDM is basically a digital multiplexing technique that combines several low rate data into one high rate one. Basically we are going to have a lot of different channels that have lower amount of bandwidth that can be combined to have a shared one higher bandwidth link. Here, as you know, TDM is a digital multiplexing technique. So that does not mean that it cannot use for analog signals. If you want to use analog signals, but the multiplexing technique should be TDM, then analog signals must be converted to digital signal first. So if you do the conversion, then you can apply TDM to those signals. So there are two types of TDM. One is the synchronous and synchronous TDM, and another was in a statistical TDM. So what is synchronous TDM? In synchronous TDM, each input will be given exactly same amount of time. However, even though each of the sources or any of the sources don't send any data, the time will be still allocated to it. It doesn't matter if the source is using this amount of time to send the data, still it will be given some time. So here we have some concepts where we have to talk about synchronous TDM, such as time slot or what are the frames. So basically time slot means that the time is given to each sources or each input lines. During that time they will transfer the data, and for frames is referring to each of those sources with the time slot given to a frame. For example, if I have three input lines or three sources, suppose I have this one. So if we do TDM, then we will have different three frames. Frames will have each of the sources timing. Let's say frame 1, frame 2, frame 3, and so on till the entire data is transferred. So in frame 1 we have three different time slots. One allocated to source 1, another allocated to source 2, and another allocated to source 3. In frame 2 we'll have the same thing. The first slot is allocated to source 1, second slot is allocated to source 2, and third slot is allocated to source 3. So this is how the frames are given, and the number of frames will depend on the number of input lines and as well as the duration of the bit. So suppose it has like 4K and each of the frame will transfer 1K bit, for example 1K bit. For each time slot it will send 1K bit, then we will have a total number of frames 4. If it does not send 1K, then the number of frames will increase. So this depends on the data that we want to transfer and the number of frames that we are going to have. So let's take a look to a simple example where some frames are shown and how the time slot are allocated. Here's an example where we have three sources, each source having some amount of time, and it is given the data how they are going to transfer. So A1 will have transferred this amount of data in this given t time, B1 will transfer this amount of data in the given t time, and C1 will transfer this data in this given time. So all the sources have three different data for transfer, and they are divided allocating this t time. So in total we will have 3 frames. Each of the frame will have slots for all the sources. For A we have A1 transfer in the first frame, A2 will be transferred in the second frame, and A3 data will be sent in the third frame. Similar goes for the both sources B and C. And the amount of time, if you look, these are equally divided. So the total amount is T, and from T time each source will get the T divided by 3 time of duration. So this is how synchronous TDM works. We will see some mathematical problems where you can be able to understand how to calculate the time slots and time durations, and how many frames we are going to need depending on the number of data that we have to send and number of input lines. Okay, let's talk about another concept. So basically TDM can be visualized as 2 first rotating switches, one on the multiplexing side and another on the demultiplexing side. This is the multiplexing side and this is the demultiplexing side, or we can think about this is the sender one and this is the receiver one. This is the receiver one. So basically these switches are synchronized and they rotate at the same speed but in opposite directions. So multiplexing will go to this way, when demultiplexing will go in this way. So these are like in reverse rotation. Their main task is basically in the multiplexing side, this switch, or we can visualize it as a switch, it will open the gate for the first connection to send data to the demultiplexing side. So we can consider this is the path, and each time the clock or the switch rotates, it will open the gate for each of the data to send through the path. So first it will send the first data, then it will send the second data, then it will send the third data, and the switch will go on. This concept of visualizing each of the data sent to from sender to receiver for demultiplexing, it is known as interleaving process. So this is all about TDM. Thank you.